Hello and welcome to the class of time series econometrics. In this class, we are going to cover a very important concept called moving average. Now, what we have seen previously is that we actually were trying to create certain models that will mimic the processes that we actually see in real life. Okay, so it is as if we are building certain tools, these tools which will actually help us to build model around the data, the time series data that we see in reality. And the way we are building tools was basically started with the concept of white noise, right? The white noise is the most basic form of time series where we have all the error terms which are IID um, are along the time series. Okay. Now using this IID error terms, what we initially did was we created a series called random walk. You remember when we added all these error terms. And secondly, what we have done is basically we created something called autoregressive of order 1, okay, AR1 process from the white noise, right? So let me write it down. So first we created, so this is our white noise, and with this white noise, with some mathematical manipulation, what we did was we did one, we created something called a random walk. Then we created something called a AR1 process. Okay, AR1 process. Now, just in the same fashion, with some changes, with some other assumptions, we are going to create another such process that we are going to call a moving average process. Okay, a moving average. In short, MA. We're going to create a MA process, and to begin with, we'll create a MA1 process. Okay, the moving average of order 1 process. So we are going to see the first part we are going to deal with that, and the next we are actually going to see how AR and MA they are different. Okay, um, so what we are doing in all this, so basically what we are doing in all this is actually creating some, introducing some autocorrelation structure. Okay, in all these different models, what we see is different is the structure of the autocorrelation. Okay, and that we are going to see how they're different between these different models. Now, uh, to talk a little more about this MA process, what we do is we actually take average MA process. We actually take average of the consecutive terms in this MA process. Okay, the average of the consecutive terms in MA process. Now, how we express an MA process? We express an MA process as like if I have my yt is the value the tth period, and I write yt is nothing but a summation of the error term at the tth period, and I actually take a weighted average of the previous period. So what I write is, say I will write theta 1 et minus 1, theta 2 et minus 2, and so on, theta n et minus n. Okay, so no read. So this is a generic form. Okay, this is a generic form of MA process. Now, what when I want to do, say, let me use a different color. So this is the generic form of MA process. Generic form of MA process. Now, when I want to do a MA1 process, like in the previous cases, what you're going to do is we are just going to take one past term, right? Only one past term. So I'll write yt is equal to et plus theta 1, or I can just simply write theta because I have just one term, theta et minus 1. Okay, so that's the MA1 process. So let me write down. So this is our MA1 process. MA1 process. And in all these cases, the error terms we already know, but let me again repeat. My error term is nothing but IID. So if I write ET, write like this. IID, okay, and I can write they follow a normal distribution where the mean is 0 and variance is sigma square. All right. So that's basically the simple mathematical way of looking at an MA process. Now, I'm just in the next lecture, I'm going to cover about the properties of MA process. And after that, we're actually going to see the interesting part, why and how MA is different from the AR process. And we're actually going to do some examples to prove that. With that, I will end this lecture here. Thank you.